Hello guys, you're welcome to this lesson. In this lesson, we are just going to consider three basic terminologies we need to understand and then we move on. We are going to look at relative atomic mass, mass number, and relative abundance. Is that okay? So in this lesson actually, I have drafted the information down so that we just go through one after the other. So the first one is atomic mass. Atomic mass is denoted by M with a small subscript A. This is atomic mass. The atomic mass is also known as the isotopic mass. The atomic mass is also known as the isotopic mass or the atomic weight. So over here I've indicated it is also called atomic weight or isotopic mass. It is simply the mass of the atom exactly equal to 1/12 the mass of one carbon-12 atom. It is the mass of the atom exactly equal to 1/12 the mass of one atom of carbon-12. It has the unit mu. Atomic mass has the unit mu or U or AMU. That is the unit for atomic mass. When I'm talking about atomic mass, it's just the mass of the atom. Is that okay? Alright. So the atomic mass is measured on what we call the carbon-12 scale. To measure the atomic mass of any element or any atom, we use a reference scale, and that scale is known as the carbon-12 scale. Is that okay? So based on the carbon-12 scale, scientists were able to measure the masses of every atom or element on the periodic table. Is that okay? So for example, the atomic mass of hydrogen is considered to be 1.008 Joule. And then atomic mass for calcium is considered to be 40.078 Joule. Is that okay? So atomic mass is the mass of the atom exactly equal to 1/12 the mass of one atom of carbon-12. Is that okay? Atomic mass is measured using the carbon-12 scale. It is just a reference scale that has been set apart to measure the atomic masses of every element or every atom on the periodic table. Is that okay? That is it for the atomic mass. Now the second terminology is the relative atomic mass. The relative atomic mass. The relative atomic mass is denoted by AR. So A and then R. So anytime you see AR, we are talking about the relative atomic mass. Is that okay? Anytime we come across AR, we are talking about the relative atomic mass. Is that okay? Alright, so it is the ratio of the average mass of one atom of an element to 1/12 the mass of carbon-12 atom. So it is the ratio of the average mass of one atom of an element compared to 1/12 the mass of one carbon-12 atom. It can also be represented as AR is equal to average mass of one atom of an element compared to 1/12 mass of one atom of carbon-12. So in relative atomic mass, we are comparing the average mass of one atom of an element to 1/12 the mass of one carbon-12 atom. Is that okay? Relative atomic mass is numerically equal to the atomic mass. But it is just that with the relative atomic mass, it has no unit. Is that okay? The relative atomic mass is just like the atomic mass, but it has no unit. Don't forget that in the definition of atomic mass, we also did mention that it is the mass of an atom exactly equal to 1/12 the mass of one atom of carbon-12. And then in relative atomic mass, the average mass of one atom of an element compared to 1/12 the mass of one atom of carbon-12. Numerically, the relative atomic mass and atomic mass, they are the same. But it is just that atomic mass has a unit of U, AMU, or MU. But relative atomic mass has no unit. Is that okay? So over here, I gave an example. AR, or the relative atomic mass of calcium, is 40.078, as the same as the atomic mass as well. But here, the atomic mass has a unit U. But in a relative atomic mass, it has no unit because it is a ratio. It has no unit. And also, the relative atomic mass of hydrogen is 1.008 without no unit. But here, the relative atomic mass for hydrogen is 1.008 joule. So atomic mass has a unit, but relative atomic mass has no unit. Relative atomic mass and atomic mass, they are just the same. Is that okay? But atomic mass numerically has a unit, but relative atomic mass has no unit. Is that okay? So with relative atomic mass or atomic mass, we are just comparing the mass of one atom of an element to a scale, and the reference scale we are talking about here is the carbon-12 scale. Now the next terminology is the mass number. So once we're talking about mass number, in our previous lessons, we learned about mass number. That is the total number of protons and neutrons in the nucleus of an atom. That is the mass number. Is that okay? But over here, we're just comparing mass number to relative atomic mass. It is the nearest whole number to the relative atomic mass. The nearest whole number to the relative atomic mass is the mass number. The nearest whole number of the relative atomic mass is the mass number. So now let's look at something here. When we take the relative atomic mass of hydrogen, we said the value is 1.008 without any unit. Is that okay? So the nearest whole number of this is just 1. So the relative atomic mass of hydrogen is 1.008. The mass number of hydrogen here can just be 1, because the nearest whole number of 1.008 is 1. And then when we take that of calcium, the nearest whole number of calcium is 40. So the mass number for calcium is 40. So once we're talking about relative atomic mass and mass number, once we know the relative atomic mass, the nearest whole number of the relative atomic mass is the mass number. Is that okay? Now I have an example here to illustrate the three information. So I have my isotopes, atomic mass, relative atomic mass, and then mass number. So in my first example, I have the isotope from chlorine. So Cl. Chlorine with a mass number 35, and then the proton number 17. And then the second example, I have chlorine again with a mass number 37 and then a proton number 17. The atomic mass for chlorine is known to be 34.97 joule. That is for chlorine 35. Its atomic mass is 34.97 joule. It has the same value for its relative atomic mass. The relative atomic mass for Cl35 is still 34.97 without any unit. Is that okay? And then the mass number, as we said, is the nearest whole number of the relative atomic mass. The nearest whole number of 34.97 is 35. So the mass number here is 35. Is that okay? Now, the atomic mass for chlorine 37 is 36.96 joule. That is the unit over there. And then the relative atomic mass is still the same value, 36.96 without any unit. Is that okay? Now what becomes the mass number? The mass number is the nearest whole number of the relative atomic mass. So the nearest whole number of 36.96 will be what? 37. So the mass number here is 37. Is that okay? So atomic mass, we're just looking at the mass of the atom. And then per definition, it is the mass of the atom exactly equal to 1/12 the mass of one atom of carbon-12. To know the masses of the individual atoms of an element, scientists set up a reference scale by using the carbon-12 element. It is the most stable element, so scientists use the carbon-12 element as the reference scale to enable them measure the masses of all the atoms or elements on the periodic table. So the mass of one atom of an element compared to 1/12 the mass of one atom of carbon-12. And that is the reference scale. So that is atomic mass. It has a unit, mu, joule, or AMU. But relative atomic mass, since it's a ratio, it has no unit. Numerically, they have the same value, but atomic mass has a unit, relative atomic mass has no unit. Is that okay? And mass number is the nearest whole number of the relative atomic mass. Is that okay? Now let's move on to the next terminology, relative abundance. Now let's talk about relative abundance.